Hey guys, welcome back. When we left off in our previous video, we were talking about critical points. And critical points are points where a tangent to the curve is horizontal or vertical. Here is a place where you have a horizontal tangent. Here's another place where you have a horizontal tangent, which means these 2 points are critical points. Those critical points happen to be the beginning or ending points of increasing and decreasing intervals. Before we actually list those intervals, let's talk about the end behavior. So on the left, as x approaches negative infinity, the y value is getting infinitely close to -1. So y approaches -1. On the right side, as x approaches infinity, y is going upward forever toward infinity. Now our intervals of increasing and decreasing. So left to right, we are first increasing very slowly, then it gets a little faster, but it stops increasing right here at this critical point. So it is increasing for x's that are to the left of, so less than 4. Then between the 2 critical points, it is decreasing, so decreasing for x's that are greater than 4, but less than an x value of 6. And then after 6, it is increasing. So it is increasing for x's that are greater than 6.
And we're going to graph x to the 5th, which is going to y equals. Figure that out. X to the 5th power out of my exponents plus x squared minus 2x minus 1 and graph. So we're going to locate and we're going to classify the extrema for this function. Now I see right here what appears to be a relative maximum. Here appears to be a relative minimum. I'm going to just draw a quick sketch so I have that to look back at later. Very rough sketch, but right here is a relative maximum, relative max at, and we'll find those coordinates. Right here is a relative minimum, relative min at, and we'll find those coordinates. To find the coordinates here, first, just to get a little bit better look, let's zoom forward. Right here is my maximum. I'm going to trace, I'm going to calculate, so that's second trace. And I'm going to trace a maximum, calculate a maximum, so option 4. And it's asking for a left boundary. I need to go to the left of that maximum. Anywhere to the left of it is fine. Enter, and then the right boundary goes to the right of that maximum. Enter, enter one more time, and I find my coordinates are negative 0.938, 1.0297, so 1.03. Then I need to find the coordinates of this minimum. So second trace for calculate, option 3, the minimum. I need to move to somewhere on the left side, to get my left boundary, enter. Over to the right side, to get my right boundary, enter. Enter one more time, and I get 0.623, negative 1.764. Go ahead and pause the video for a moment and try the next one. We'll go back to y equals, clear that out, and type in the next equation, x to the 4th power plus 4x squared. And I did not get out of the exponent. So we're at x to the 4th power plus 4x squared plus 2x. Graph. Okay, so we've got a parabola. And I need to locate that point right there. Now that is the lowest point on the entire domain of this graph, so I know it is going to be an absolute minimum. Now I need to find its coordinates. Second, we'll calculate, it's a minimum, option 3, a left boundary and a right boundary. And between those boundaries, enter one more time, we have a minimum of negative 0.243, negative 0.246. Last, determine whether the critical point is a maximum, a minimum, or a point of inflection. So we'll go back to, actually first let's change our zoom to 6 with a standard view here. And then type in x squared plus 6x plus 4 and our y equals. Clear that out. X squared plus 6x plus 4. Graph. And where x is negative 3, appears to be right about there. Is that a maximum, a minimum, or a point of inflection? So here's how we're going to tell for sure. We're going to make a table. The calculator's going to make a table for us. So we're going to go first to table set, second, and then windows for table set. And table start, let's start it at that critical point of negative 3. And for a triangle, that means it's read as delta, which in math means change, so the change in the table. Let's make that, instead of 1, let's make it 0.1. And then, second, and graph to get us our table. And what we can see is, starting at x equals negative 3, then negative 2.9, negative 2.8, here's our outputs. Now let's just go up one touch so we can get something on either side of our critical point. So here's an XY chart. At negative 3.1, it's negative 4.99, that's our output. Negative 3, the output is negative 5. And at negative 2.9, our output is negative 4.99. This right here, at x equals negative 3, is the lowest output on that portion of the domain, which means this is a minimum. So our critical point here is a minimum. Go back to y equals, clear out that last equation, and put in x cubed. minus 6x squared plus 12x minus 7. Incorrect. At x equals 2, is that a maximum, a minimum, or a point of inflection? So here's how we tell. We go to our table set, and we'll use our critical point as our table start. 2, we'll keep our change in table at point 1, and then go to our table. Second graph, let's just go up 1, so we see something on either side. So we have an input of 1.9 and an output of 0.999. Input of 2 gives us an output of 1. Input of 2.1 gives us 1.001. Notice this point right here is higher than the output at our critical point, and this output is lower than the output at our critical point, which means this is a point of inflection, an inflection point.